Assalamualaikum everyone. Okay, in this video we'll talk about improper fractions. Up till now we have seen in the previous videos about proper fractions. Now let's see what is improper fraction. See here. Improper fraction, the degree of g of x is less than or equal to degree of f of x. We know the fraction is in the form of f of x by g of x, right? Okay, my fraction is in the form of f of x by g of x. So I'm saying, so improper fraction is if the degree of this f of x, the numerator, is greater than or equal to g of x, then it will be an improper fraction. ठीक है, मेरा न्यूमरेटर बड़ा भी नहीं होना चाहिए ना इक्वल होना चाहिए. The degree of numerator should not be equal to g of x, nor it should be greater than g of x. Okay, the denominator. See, in the previous videos we have seen about proper fractions, right? Therein we have seen how to solve the proper fractions. We have got 4 different types. Depending upon the denominator, we had 4 different types. So if we have an improper fraction, how are we going to solve it? We are first going to change it into proper fraction. Then we are going to, depending upon the denominator, we'll see the denominator. Then depending upon the denominator, we have 4 different types, right? We'll solve accordingly. Okay, so let's see an example here of improper fraction. See, here if you see the denominator, if I multiply this, I've got 2 factors, right? If I multiply this, x into x will be x square. So the denominator is having the degree 2. But if you see in the numerator, the highest degree is 2. So 2 is equal to 2. Here it is 2 is equal to 2. That means it is an improper fraction, right? Now next one. Here if you see the numerator is having the highest degree as 4, whereas if you see in the denominator, if I multiply this x square with x, it will be x cube, right? The highest degree is what here? 3, that is cube. So if you see 4 is greater than 3, that means the numerator is greater than the denominator. The degree of numerator is greater than denominator. So such problems falls under improper fractions, right? Okay, so for these problems, these 2 problems, or for these improper fractions, first we are going to convert it into proper fraction with the help of long division method. Okay, long division, I hope you people know how to do it. Long division is just like division. The only difference is that you, instead of having numbers, you will have variables in them. Okay, so we'll take one example and see how to solve improper fraction. Let's quickly look into an example. Here, suppose this is my question, 3x cube plus 2x plus 1 by x into x square plus 1. So here if you see, if I multiply this x inside, x into x square is x cube, into x into 1 is x, right? So here highest degree is what here? 3. The denominator is having the degree 3, and in the numerator as well, if you see the degrees, highest degree is 3. So 3 is equal to 3. So that means this is an improper fraction. So for solving improper fraction, we need to first do the division method. Here, this is my denominator, right? Denominator being divided with the numerator. See, x cube plus x, and this is my question. So here if you see, I have x cube. The first term if you see, 3x cube. में मेरे पास x cube है. I need what? 3. If I multiply 3 with this x cube, I'll get 3x cube, right? So I'm multiplying 3 here. So x cube into 3 is 3x cube. But I also have one more term here. Plus x भी है मेरे पास. So this plus x will also be multiplied with 3. So x into 3 is 3x, right? Now changing the signs. This is positive, so I'm changing it to negative. This is positive, I'm changing it to negative. See here now. This term is positive and this term is negative. Both gets cancelled out, right? Next. Minus and plus. Okay, 3 minus 2 is 1. So 1x here, x. The bigger number is having negative sign. So minus x. Now this plus 1 I'm bringing down. So it will be minus x plus 1. So here if you see, x, the highest, what we say, the highest degree here is 1, whereas the highest degree here is 3. So I cannot solve it any further, right? So I need to stop here. So here, this is my remainder, right? This is my quotient. Okay, so this is my actual question, right? Now it is being reduced to this form after this division. Here, quotient plus remainder by this divisor. Okay, q is quotient plus remainder by divisor. So the quotient is here what? 3 plus the remainder minus x plus 1 can also be written as 1 minus x. First I am writing 1, then I am writing minus x. I can write like this, right? So the remainder 1 minus x, then this x cube plus 1 भी लिख सकते हैं हम यहाँ पे x cube plus 1 और this one x into x square plus 1, both the things, you can write both the things. Okay, I am writing x into x square plus 1. Now this is my actual question. Okay, from this question if you see, this is my actual question. No, from this question if you see this part, forget about this 3, this part is my fraction, right? This is my fraction and I've got two factors, one is x and the other is x square plus 1. So I'll take this part, only this part. For now I'll forget about 3, I'll take this part from the question and now I'm going to solve it, decomposing it into partial fractions. The first factor is x, which is linear. Okay, so it will be simply a constant over factor, plus the other factor if you see x square plus 1. X square plus 1 means it is a quadratic factor. So for quadratic I am having bx plus c. Okay, partial fraction will be bx plus c. This is type 2 we know by the factor itself. Now let this be my equation 2. Now taking LCM will be x into x square plus 1. Now cross multiplying, a will be multiplied with x square plus 1 and bx plus c will be multiplied with x. Now I have both the denominators common, so I am going to cancel this out. Okay, now what I am left with, 1 minus x is equal to a into x square plus 1 as it is, plus this bx is being bx plus c. These are two terms, one is bx and the other is c. These both are being multiplied with x, so I am going to write it separately. Bx ko I am writing separately, c ko I am writing separately. Now bx into x will be bx square, x into x is x square. Now c into x is cx. Okay, now let this be my equation 3. Now once I get my equation 3 here, I am going to find out a, b and c, the values of a, b and c. For finding the values, first what I am doing, see the factors I have is x and x square plus 1. So first factor, I'll take first factor and I'll equate it to 0. Mera first factor is x, so I'm equating it to 0. So x equal to 0. That means what? The value of x for now is 0. So wherever I find x in equation 3, I'm going to write 0 instead of that. So here 1 as it is. X ki place mein I need to write what? 0. Then a into what is x? 0. 0 square. 0 square is 0. Plus 1 as it is. Plus b into 0. Plus c into 0. So 0 into anything becomes 0. 0 into anything becomes 0. Here this will be plus 1. So a into 1 is a. 1 minus 0 is 1 only. So a is 1 is equals to a, yeah, a equals to 1. So that means the value of a is 1. We found a. Now for finding b and c, see here. In this equation, what is the variable with the highest degree? The highest degree in this equation is square, right? X square is the variable. So we'll compare the coefficients of x square on both the sides. So see here, the case 2. Do I have any x square term here on the LHS? No. So 0. On the RHS, see, a into x square is ax square. So x square ka coefficient is what now? A. So a. I have to write the coefficients, okay? The coefficients. Now plus bx, bx square. X square ka coefficient here is b. So plus b. Now see next. Do I have any x square term here? No, I don't have. Now we know the value of a. That is 1. So substituting 1 in place of a plus b. Here 1 is being added. So goes on the other side. Subtracts. Okay. I'm sending this 1 to the other side. So now b value is what? Minus 1. Okay, after x square, what will be the next term? X, right? Now case 3, comparing the coefficient of x. So let's see, do I have any x term on the LHS? Yes, this minus x matlab minus 1x रहता है, right? The coefficient will be minus 1. So x का coefficient is minus 1. Now next, do I have any x term here? No. Do I have any x term here? No. But I have an x term here. The coefficient is c. So c. So directly we got the value of c. C is now what? Minus 1. I got 3 values, a, b and c. Now I'll substitute in equation 2. Okay, this was my partial fraction, right? I'll substitute here. Now the value of a is 1. So 1 by x. 1 by x. Plus what is the value of b we got? Minus 1. So minus x plus c. Minus 1x plus c or minus x plus c, one and the same. Then next, the value of c here is minus 1. So minus 1. Right? Now this became what? Minus x minus 1. This part I am saying. X square plus 1 whole square. So I can write it like this, right? Can I take minus common here? Yes, I am taking minus common. So I will be left with x plus 1, right? By x square plus 1 whole square. So यही term को I am writing here down. Plus into minus is what? Minus. Forget about this. This is the intermediate steps. The final is here. So plus into minus is minus. Then instead of writing this, I am writing this. X plus 1 or 1 plus x is one and the same. 1 plus x by, keep this in brackets. Now by x square plus 1 whole square. This is done. But this was only my partial fraction. My actual question is this, right? So I need to include this as well. So this partial fraction, this partial fraction. Now let's write this partial fraction into this equation. We get what? 3x cube plus 2x plus 1 by x into x square plus 1 is equal to 3 as it is. Plus what was the answer I got for partial fraction? This. So 1 by x minus 1 plus x by x square plus 1 whole square. Okay, that's it. If you want to take a screenshot, you can take it. Okay, so that's it about improper fractions. I think you people understood what an improper fraction is, right? If the degree of the denominator, that is g of x, if it is equal or if it is less than the numerator, then it is called as improper fraction, right? The denominator should not be smaller, it should be greater. It should not be equal as well. Okay, so that's it about improper fractions. I hope it is clear. If you still got any doubts, then ask me, DM me or comment it down in the comment section below. Okay, so that's it. Thank you.